Okay, so we're on to lecture 10 on series, which is the last lecture in section 11.2. We're actually not going to get to this in class, but I just want to, because it's kind of a special situation, but I wanted to point out what can happen sometimes when you're dealing with series. This is a series, this series is kind of interesting because it's what we call a collapsing series. Because I'm going to rewrite this in terms of partial fractions. Let's just rewrite this. This is going to be some constant over I plus some constant over I plus 1 plus 1. And if you notice, that can be written as A times I plus 1 plus BI over I times I plus 1. And when I solve for the right i's, of course, the numerators have to be equal for any I. So if you recall when we did partial fractions, A times I plus 1 plus B times I plus I have to be equal for any I. Even though the denominators, we can't have I equal negative 1 and 0, the numerators still have to be equal for that. That is, if I equals 0, A is equal to 1, right? And if I is equal to, what's the other thing, negative 1, we get B is equal to negative 1. Go ahead and put in those i's and you get that in that equation. So in other words, this series is equal to the sum I equal 1 to infinity of 1 over I minus 1 over I plus 1. So let's look at the partial sums of these series. Let's look at the fifth partial sum, I equal 1 to 5 of this thing. Oops. Edit. Undo. Of 1 over I minus 1 over I plus 1. So this is going to be 1 over 1 minus 1/2, right? Plus 1 over 2 minus 1/3 plus 1 over 3 minus 1/4 plus 1 over 4 minus 1/5 plus 1 over 5 minus 1/6. And what do you have to notice here? Well, this minus 1/2 and this positive 1/2 cancel. The minus 1/3 and the positive 1/3 cancel. The minus 1/4 and the positive 1/4 cancel. The minus 1/5 and the positive 1/5 cancel. And I'm left with what? I'm left with 1 minus 1/6. So if you check in general, if I go from I equals 1 to n of 1 over I minus 1 over I plus 1, that's going to end up being 1 minus 1 over n plus 1. So now, as n goes to infinity, what's happening? As n goes to infinity, this term here goes to 0. So the entire thing here goes to 1 minus 0, which is 1. So this is the limit of those partial sums, which is going to be 1. Okay, so the idea is a collapsing sum is something that you can actually write in such a way where terms actually cancel each other, like this one. That's called a collapsing sum. And you should be aware that this can sometimes happen and think to look for it. It doesn't happen that often, but when you've got a partial fraction situation, try it. And that's about all I want to say for that.